All right, so in assignment number 8, we're actually going to be solving radical equations. We've been simplifying radicals, multiplying, dividing, and adding, subtracting radicals. Then we use radicals to find lengths of sides using the Pythagorean theorem. We did radical binomials, and now we're actually going to look at some radical equations. Let's just take a look at a radical equation with some applications that we might find useful. Here's a radical equation right here that will be able to tell us how long it will take an object to fall if it were dropped from a certain height. And so you see here a picture of One Summit Square, which is in downtown Fort Wayne. And suppose we were able to go up here and we were able to drop something from the side of the building onto the ground below. One Summit Square is 442 feet high. So the question is, how long would it take for an object to hit the ground if it were dropped from that distance? And so what we would do is we'd simply, to find the time, we would simply plug in the height of the building for our distance. So it's going to be the square root of 442 divided by 16. So the first thing we could do is we could take 442 and divide it by 16. That's going to give us roughly 27.265. 27.265. And if we take the square root of 27.265, we would have about 5.22 seconds. So if we were to drop something from the height of that building, it would take 5.22 seconds for it to hit the ground. So let's take a look at a different building. You might recognize this building also from downtown. It's the Fort Wayne National Bank building downtown. It is 339 feet high. So if we use the same formula, remember the formula is D equals the square root of whatever the distance is divided by 16. So if we plug 339 in here, we're going to have 339 divided by 16. And there's actually a couple ways I could have done this. I could have taken the square root of 339 over the square root of 16. But I'm going to go ahead and do it the same way we did it last time. I'm going to take 339 divided by 16, and that gives us 21.1875. So it's the square root of 21.1875. And if we take our calculators out and plug in the square root of 21.1875, we would get close to, not exactly, but close to 4.6 seconds. So it would take 4.6 seconds if something was at the top of this building and we dropped it off the building. It would take 4.6 seconds for whatever it was to hit the ground. So let's compare that to another building that you might be familiar with. This is a picture of the Willis Tower in Chicago. And it is a known fact that if you did drop something off the Willis Tower, it would take 9.5 seconds for the object to hit the ground. So suppose we wanted to use that to find out how tall it was. So remember, our equation is this. The time that it would take is equal to the distance over 16, the square root of that. And so in this case, the other two cases, we knew the distance, but we didn't know the time. So here we know the time. So we're going to plug in 9.5 seconds for the time and set that equal to the square root of d over 16. And now we're going to be working in the opposite direction from what we just did. We want to solve this equation for d. And so the first thing we're going to have to do is get rid of the square root sign. And one way to get rid of the square root sign, the best way to get rid of the square root sign is to square both sides. Because if I square both sides, then I have two of these inside. And remember, we pull them out in pairs. And so that's just going to give us d over 16. And that's going to equal 9.5 squared. And 9.5 squared is 90.25. But I want to get d by itself, and I'm dividing by 16. So at this point, what I'm going to do is multiply both sides by 16. If I multiply this side by 16, they cancel out. If I multiply this side by 16, then I'm going to end up with D, the distance or the height of the Willis Tower is going to be 16 times 90.25. And, oops, I did that wrong on my calculator. 16 times 90.25 is 1,444 feet high. Now, if you compare that to the buildings that were in Fort Wayne, remember, this is 1,444 feet high. The tallest building in Fort Wayne was 442 feet high. That means that the Willis Tower, if you stack this building on itself 3 times, the Willis Tower would still be taller than that building in downtown Fort Wayne. So that just gives you an idea of how our tallest building here in Fort Wayne compares to the tallest building in Chicago. It's about a third. So let's use this idea then to solve other radical equations. A radical equation is simply an equation with a radical in it. And so here we have the square root of 3x plus 7 equals 19. In order to solve this equation, we're going to start by subtracting 7 from both sides. So we would get the square root of 3x is equal to 19 minus 7 is 12. But then I want to get rid of the square root sign. So the way we undo a square root sign is by squaring both sides. That will leave us with 3x equals 144. And then if I divide both sides by 3, I will have on the left-hand side x, and on the right-hand side I'll have 144 divided by 3, which is 48. And the nice thing about solving equations is you can always plug it back in to make sure that you're correct. So if we took 3 times 48 and then took the square root of that and added 7, we should get an answer of 19. I'm going to have you try this one on your own. Pause the video and then see if you can start the video back up and see if what you had was correct. Hopefully you were able to do that, and hopefully the first step that you did was to get rid of the radical sign first, because we can't get rid of the 7 first because the 7's inside the radical sign. So if I square both sides, then this radical sign disappears. We're going to have n plus 7 on the left-hand side equals 10 squared, which is 100 on the right-hand side. Then if we subtract 7 from both sides, we will get that n is 93. Let's take a look at a few more that are a little bit more complicated. Just 2 more actually. Let's start by, eventually want to get the n by itself, but we have to work kind of from the outside in, which means we're going to start by getting rid of adding 12. So I'm going to subtract 12 from both sides, and if I do that, I will have 4 times the square root of 2n plus 8, still in the radical sign. But if I subtract 12 here, it disappears, and if I subtract 12 here, it's now going to be equal to 24. So it's a little simpler at this point. But I still have the 4 on the outside of the radical sign, so I'm going to divide this side by 4 and this side by 4. The 4's will cancel, and I will have the square root of 2n plus 8 equals 24 divided by 4, which is 6. Well, then I can get rid of the square root sign. So I'm going to square both sides, which means the radical sign will not be there anymore. It'll just be 2n plus 8 equals 6 squared, which is 36. If I subtract 8 from both sides, then I'm left with 2n equals 36 minus 8, which is 28. And if we divide by 2, we get our final answer, which is 14. So n is 14. And again, you can plug 14 back in for n in the original equation here and make sure that this whole side does give you 36. Let's try one more. Pause the video here, see if you can solve this last one on your own, and then start the video up and make sure that you have it correct. Hopefully the first thing that you did was subtracted 6 from both sides. So we get the square root of x equals negative 4. Now, this is kind of a trick question here because it's impossible for us to take the square root of something and get a negative number. You might say, well, the square root of negative 16, but the square root of negative 16 is 4 because, or the square root of negative 16 can't be done because negative 4 times negative 4 is positive 16. Even if we squared both sides, let me just show you what would happen here. If we squared both sides, then we would have x equals negative and then 4 squared, which would be negative 16. But if we plug negative 16 back in here, it can't be done. We can't take the square root of a negative 16. It's not negative 4 because negative 4 times negative 4 is positive 16. So if you ever have something like this where you have a square root of a number and the square root's by itself and it's equal to a negative, it is simply no solution. And so you will have some examples on your homework where you get something that just doesn't have a solution, and that's what's going on in this situation. So that's what our homework assignment looks like for tomorrow. Do your best on that, and we'll go over questions that you have tomorrow in class.